Right, this is AS Maths October 2020, paper 2, the stats, question 4. We'll have a look at that first. So, a lake contains 3 different types of carp, but there is a question in the Edexcel book that was very like this, and also I think it's even an example. Anyway, so there are estimated 450 carp, 300 leather carp, 850 common carp, so it was mirror carp. He wishes to investigate the health of the fish. He wants to take a sample of 160. Give a reason why stratified random sampling is not used. It's only 1 mark. So stratified random sampling, you would decide how many in each group to get. And then that's kind of the stratified bit, which is also part of quota, really. You kind of decide how many of each you want to get, and you want it to be representative. That's the whole point. And then within each group, you would then randomly select what you're looking for. To make a random sample, you have to have a sampling frame, as in you've numbered, given everybody a number, and then you randomly choose a number, and then you pick that person. These fish, 450 mirror carp fish, will look the same. There is no way you're going to know, well, first to be able to number them, and second to be able to find that one, especially in 450 mirror carp in a lake. So the biggest issue here is basically if I could spell, it is not possible to produce or there's no way you could do that, produce a sampling frame for the fish in a lake. So that's that one done, 1 mark. Okay, explain how a sample of 160 would be taken to ensure that the estimated populations of each carp are fairly represented. Use name, so I've already kind of mentioned it. This is quota, so we're going to, it's quota sampling. You're going to specifically say I want some of each, and you want it to be representative. So if we think in total, you've got I'm going to have to pull it down again. There we go. 450 mirror carp, 300 leather carp, never heard of any of this, 850 common carp, that adds up to 450 plus 300 plus 850, 1,600, and they wanted 160, so you can see that is just 10%, so this is going to be 45, 30 and 85 of each, and it's a quota sample. And then if you catch, I suppose, if you catch a fish that has already achieved its quota, return to pond as not needed. So you just want to fill your quota for that. That last bit is just kind of a bit like when you do your random sampling. If you get the same number again, you ignore it. So you only look at the ones that you need. It's a bit like that, but you only want to fill that. You don't want 46 here. I want 45. I don't want 44. And that's what you do. Okay, so that's that. Next bit, I think I need to delete this then. So the next bit we're looking for is as part of the health check, he wants to check the weights. So we've got this information, calculate an estimate for the standard deviation. So standard deviation has got a formula like this, sum of x squared over n minus the mean squared. And when it's in a table, so that would just be for data, when it's in a table, you've got the sum of fx squared over the sum, the frequency, which is the total of them, like the n, the total, minus the mean, which instead of putting mean, I can put the sum of the fx's over the sum of the f's, all squared. It's exactly the same formula. It's just taken into account you've got to that you've got the frequency and in actual fact the midpoint. But anyway, so in this case we have got the square root of 3053 over, I think that's the 160, minus 692 over 160 all squared. So you're just subbing into a formula that you have there in your 3053 over 160 minus, open bracket, thingy, 692 over 160, close bracket, squared. So I've got 0.6128825336, and because at the front it says round to 3 sig figs, that is what I'm going to do. Okay, so that's that one then. And then Tim realised, so that's another 2. Tim realised he had transposed the figures for 2 weights. He had recorded 2.3 instead of 3.2 and 4.6 without calculating a new estimate to describe what effect. 1, the first thing. Okay. Well, the first bit, 3.2 instead of 2.3, both of those are in the same class group. So spread of data not affected, therefore standard deviation will not change. Okay, and the second one, using the correct 6.4 instead of 4.6. Okay, 4.6 is here, 6.4 is here, so it's creating a new column. So as 6.4 is above maximum at the moment, it will increase the spread of the data, hence it will increase the standard deviation. Good, hope that's okay.